Hey guys, in this video we're going to focus on finding higher order derivatives. So let's say we have the function f of x equals x to the fourth plus 2x cubed plus 5x squared plus 7x plus 1. And the problem statement is asking us to find all higher order derivatives. This essentially means that we need to continue deriving this function until the right-hand side of the equation equals 0. To begin, we first find the derivative of the function f prime of x. This notation simply means the first derivative. So first, the derivative of x to the fourth is 4x cubed minus the derivative of 2x cubed, which is 2 times 3x squared plus 5 times 2x plus 7 plus 0. The derivative of a constant is 0. And then we'll just simplify this function so it's easier to keep deriving, because we'll have to keep deriving this equation until the right-hand side of the equation equals 0. So f double prime of x, or the second derivative of f of x, equals 4 times 3x squared minus 6 times 2x plus 10 plus 0. Simplifying that down further, we have 12x cubed, x squared minus 12x plus 10. Moving to the third derivative of x, 12 times 2x minus 12, which simplifies down to 24x minus 12. And then one more time, the fourth derivative of x equals 24. So the fifth derivative equals 0. Really quick, there's a way that we can check our work with these types of problems, and it's this theorem, which says if p of x is a polynomial of the degree n, then f of n plus 1 of x equals 0. So what that simply means is, if we look at the original problem statement, the original f of x, we notice that the highest exponent is 4. So this theorem says f of 4 plus 1, or the highest exponent in f of x, equals 0, meaning the fifth derivative of f of x will equal 0. And you can see above that we did get that answer, which simply verifies that we did the problem correctly. If we didn't do the problem correctly, then the fifth derivative may not be 0, and it would be a quick way to tell us that we need to go back and redo our work. The next problem asks us to find the third derivative of the function f of x equals the square root of x. This simply means we need to derive the function 3 times. So the first step I would take in this problem is converting f of x equals square root of x into f of x equals x to the power of 1/2. This will simply make it easier to find the first derivative of x. So we move the 1/2 down in front of the x, and then we subtract 1 from 1/2. I think it's easier to subtract 2 over 2 to find that the derivative is 1/2 times x to the power of negative 1/2. So deriving this again, we now have to put negative 1/2 in front of the x here and subtract by 2 over 2 once again. So we find that f double prime of x equals 1/2 times negative 1/2 x to the power of negative 3 over 2. So we just want to be careful with our signs here and make sure to carry through the parentheses as we go so we don't make any simple mistakes. Just to simplify that further, that is the same as negative 1/4 times x to the power of negative 3/2. Deriving that for the third time, remember we're putting now negative 3/2 in front of the x and subtracting 2 over 2 in the exponent. So the third derivative is negative 1/4 times negative 3/2 x to the power of -5/2. Simplifying that further, that equals -3/8 x to the power of -5/2. And that answer is good as it is, but just for completion, we can rewrite that as -3/8 root x to the 5th. Because if we'll recall, if there's a negative exponent, that's the same as -3/8 x to the +5/2. And then we can just simply convert this into the radical form. This problem asks if the second derivative is 3/x, find the fourth derivative of f of x. So this is mostly a question to test whether or not you understand this notation. If you grasp that this is the second derivative of f of x and this is the fourth derivative, then you'll understand that you simply need to derive this function twice in order to find f4 of x. So similar to the previous problem, the first step I would take to solve this derivative is to change the form 3/x into 3x to the power of -1. That's a little trick to help make taking the derivatives of these functions much easier. We see that we'll move the -1 in front of the x and then subtract 1 from the exponent. So we get 3 times -1 x to the power of -2. In other words, -3 x to the power of -2. Now to get the fourth derivative of this, we move the -2 in front of the x and subtract 1 from the exponent once again, and we get -3 times -2x to the power of -3, which simplifies down to 6x to the power of -3. And we could leave it like this, but I think it's better to convert this to 6/x cubed, because the exponent up in the negative exponent up in the numerator just means that we can move it to the denominator as a positive value. So some key takeaways on this topic is when you're taking derivatives, you're going to want to make sure you convert all radicals to their exponent form to just make it much easier to take the derivative. And then for the questions you'll see where you need to find all higher derivatives, you can always verify your answer with the theorem if p of x is a polynomial of degree n. So the highest degree exponent in f of x, then that value plus 1 will get you the derivative where the right-hand side of the equation equals 0. And then the second takeaway is to just understand the notation of these problems. So if you understand that 1 prime means the first derivative, 3 primes means the third derivative, and you can also write it with a numerical 4 here, which equals the fourth derivative, then I think you'll have no problem understanding what these problems are asking and being successful on the exam. So that's it for this video. I hope that was helpful. If you like this video, please like and subscribe, and let me know if there are other types of problems that you'd like to see examples of. Good luck, everybody, and see you next time.